Section 6.3, dividing polynomials. Our objectives are to divide polynomials using long division, also using synthetic division, and we're going to talk about the factor and remainder theorem. So for our first example, we're dividing 60 by 12. So remember that when we set this up, we can do our equation like this, where 60 is called our dividend, 12 is our divisor, our answer is called our quotient, and what's left over, if we have anything, would be our remainder. So I want to see how many times does 12 go into 60. I know it goes in 5 times. So 5 times 2 would be 10. 5 times 1 would be 5, plus 1 is 6, so 60, and then remember you subtract your answer, and the 0 would be my remainder. So because of that, we say, so that means that 5 and 12 are factors of 60 because 5 times 12 equals 60. So for the next one, same thing, we want to do 62 divided by 8. So I want to see how many times does 8 go into 62. Well, I know 8 times 7 is 56, and 8 times 8 would be 64, so it has to be 7, because 64 would be too much. So 56, and then subtract. So this gives me 6 for my remainder. So for this one, I would say neither 8 nor 6 are factors of 62, because in order to get 62, we have to do 8 times 6 plus the remainder would give me 62. So that's important to know, because if the division has a remainder of 0, then both the quotient and divisor are factors of the dividend. If the division leaves a remainder, then neither the divisor nor the quotient is a factor of the dividend. So make sure you know that. The same is true for polynomial division. If you divide a polynomial by one of its factors, you get another factor. When a polynomial leaves no remainder, you have the factor of the polynomial. So for the first one, remember when we're doing division with polynomial equations, you always want to make sure your dividend is in standard form, and if you need 0 placeholders, you can add those in as well. So if I divide this one, I would see how many times does x go into 6x squared. I always like to do my math off to the side, as you remember from before. So it goes 6x times. So line up your terms. 6x times x would give me 6x squared, and then remember we subtract the terms. This cancels out, so I'm left with 0, and I don't really need to bring down 0. So my answer would be 6x. Because 6x times x gives me 6x squared, and the remainder is 0, I know that 6x and x are factors of 6x squared, because 6x times x equals 6x squared. So let's do the next one. For the next one that we have, again, make sure your divisor, which is right here, is in standard form with no missing 0 placeholders. So then I always like to see, I need to figure out how many times does x go into x squared. So if I do my math off to the side, I know it goes in x times. Remember to line up your terms, and then you take that x and multiply it by this x, which gives me x squared, and then x times -5 is minus 5x, and again, line up your terms. Remember, when we do this, we have to change the signs of our equation, so this would be minus, and this would be plus. I always like to circle them so I don't forget that I changed them. This cancels out, which we did on purpose. This gives me 7x, and then I bring down -30. And then I start all over again. So now I want to see how many times does x go into 7x. So it goes 7 times, so that would be plus 7. 7 times x is 7x. And 7 times -5 would give me -35. And then don't forget, we need to change our sign, so this would be minus and this would be plus. This cancels out, which we did on purpose, and I'm left with 5 for my remainder. So because I'm left with 5 for remainder, I know that x plus 7 and times x minus 5 are not factors of x squared plus 2x minus 30. But, so I'm going to say x plus 5 and x plus 7 are not factors of x squared plus 2x minus 30, because if I multiply those two together, I don't get that polynomial equation. However, if I do x plus 5 times x minus 7, and then add my remainder, I would get x squared plus 2x minus 30. Even just to show you real quickly, so this would, if I FOIL this out just to check my answer, x times x would be x squared. Then we have minus 7x plus 5x minus 35 plus 5. Combine like terms, x squared minus, so this would be, sorry, that should have been plus 7x. So this would be plus. And that 5 was minus. So minus. So this would be plus, and this would be minus right here. So that would give me plus 2x, and then 35 and 5 would be minus 30. So that would give me this answer right here. And because of that remainder part, we know that they are not factors of the given polynomial. So this right here is what I just showed. Recall that another method of dividing a linear factor is using synthetic division. Remember that we have specific rules for using synthetic division. Synthetic division can only be used when the divisor x minus c is a polynomial of the first degree. It must be written in standard form, so remember you always need to add in those 0 placeholders. Remember that we take out the variables and exponents, reverse the sign in the divisor, and you're going to add instead of subtract when you do synthetic division. So for this one, it says you can use polynomial division to determine whether x minus 8 is a factor of the dividend. And how do we know if it's a factor or not? We're going to look to see. So look to see if the remainder equals 0. And that's how we would figure out if it's a factor or not. So again, I can do synthetic division and I can do long division. So let's do long division first, just to practice. So x minus 8, and then I'm going to, underneath for my dividend, I have 2x squared minus 19x plus 24. So it's in standard form. I wasn't missing any 0 placeholders, so I didn't have to add them in. So I want to see how many times does 2x squared, how many times does x go into that? So 2x times, line it up. Multiply, so we have 2x squared. 2x times negative 8 gives me negative 16x, and then don't forget that we got to subtract or change our signs, so that cancels out, and then I'm left with negative 3x plus 24, and then do the same thing. Negative 3x, how many times does x go into it? Negative 3 times. So negative 3 times x is negative 3x. Negative 3 times negative 8 gives me 24. And then change the sign, so this would be plus, this would be minus. So this cancels out and this cancels out to leave me with a remainder of 0. If I want to do my synthetic division, remember that's when we take out our variables. So I do 2, negative 19, 24. And remember we have a number that goes in my box here. And then instead of subtracting, we add. The number that goes in the box, we use the opposite of negative 8 would be positive 8. And how do you find that number? You just set it equal to 0. So x is equals 8 is what we're testing right there. Remember, you bring the first number down. 2 times 8 gives me 16. Add these two numbers together. And then negative 3 times 8 gives me negative 24. Add these two numbers together. Remember, the last number is your remainder, and then you add your x's back in. So if your dividend is an x squared, you do one less than that. So this would be 2x minus 3 for my quotient or my answer. So because my remainder is 0, we know that x minus 8 and 2x minus 3 are both factors. So I would say x minus 8 and 2x minus 3 are both factors of 2x cubed or 2x squared minus 19x plus 24. So that means if we were to multiply x minus 8 times 2x minus 3 together, it would give us this polynomial equation right there. All right, so for the next examples, it says use synthetic division for the following. So for these equations, what I would do is pause the video and then unpause it to check your answer. So for the first one, again, make sure you're in standard form with no missing zero placeholders, which we are. So this would be, remember, you use your coefficients, 1, 4, 1, negative 6. Since this is x plus 1, that means negative 1 goes in here. Remember, we're adding, bring down the first term, and then would be 1 times negative 1 is negative 1. Add those two numbers together, you get 3. 3 times negative 1 is negative 3. Add together, get negative 2. Negative 2 times negative 1 gives me positive 2. Add together, and we get negative 4, which is my remainder. So then this equation right here becomes 1 less than your dividend, which is an x cubed, so x squared plus 3x minus 2 minus 4 over x plus 1, because that's my remainder. So this would be my solution, and therefore I know that x plus 1 is not a factor of that polynomial equation because the remainder is equal to negative 4. So then for this other one over here, you're going to do the same thing. So in my box goes negative 1, then we have 3, negative 4, 2, negative 1. We are adding, bring down the first term. And then since this is a degree 3, this would be 3x squared minus 7x plus 9 minus 10 over x plus 1. And again, since we have a remainder of negative 10, I know that x plus 1 is not a factor of this polynomial equation either. For the next equation, it says determine if x minus 3 is a factor of x squared plus 3x minus 12. So to do this, you can either use synthetic division or long division. Remember, again, for synthetic division, this divisor has to be a polynomial degree 1 with nothing in front, which it is. So in the box goes the opposite, which would be 3. And then this has to be in standard form with no missing zero placeholders, which it is. So when I do this, I get my quotient or my answer, which is x plus 6, because oh, sorry, this should have been, I didn't realize I did that. This should have been 18, because 6 times 3 is 18, which gives me 6. So this would be x plus 6 plus 6 over x minus 3. So because the remainder is 6, that means that x minus 3 is not a factor. Now, for this, let's try something new. So let's do p of 3 into my equation. So if I do p of 3 into my equation, you would get, so if I plug 3 in, I would get, in this equation, 9 plus 9 minus 12. And then notice that gives me, when I add and combine like terms, equal to 6. So that means that p of 3 equals 6. Well, that's interesting because wasn't that the remainder that I got? So the question is, why does that happen? So p of 3 equals the remainder in our example. Why does this work? Remember that the divisor times the quotient plus the remainder equals your dividend, which you started out with. So in this case, just to show you, if I did p of x would be equal to x minus 3 times x plus 6 plus my remainder, which is 6. Because this right here, if I multiplied it and added 6, would give me my original polynomial equation that I started off with. So if I, into this equation, do p of 3, notice that I would have 3 minus 3 times 3 plus 6, and notice 3 minus 3 is 0, times 9 plus 6, which is just 6. So when you plug in 3, it makes your divisor part that you have equal to 0. So really you're doing p of 3 is equal to 0 times the quotient plus your remainder. And 0 times anything is just 0, so that's why you're going to get the remainder for your answer. And this will happen every single time. That's where we get this next theorem, which is called the remainder theorem. So the remainder theorem says, if a polynomial p of x of degree n, where n is greater than or equal to 1, is divided by x minus a, where a is a constant, then the remainder is going to be p of a, whatever that x minus a, whatever that a is. And the factor theorem states that a binomial x minus a is a factor of the polynomial f of x if f of a is equal to 0. So that means that we have a remainder of 0, and that's basically what all of this right here says as well. So for some examples, just to show you, it says use synthetic division to find p of -4, and then showing that that's going to give us our remainder. So for this one, if we do synthetic division, if it's p of -4, then p of -4 means that if I write this as a linear factor, it would be x plus 4, because remember it's always x minus the number. So that means for my synthetic division, my box goes -4. And then we have 1, we're missing 0x cubed, so 1, 0, -5, 4, and 12. One times -4 gives me -4. This would be 16. So notice I get this polynomial equation right here. So if I plug -4 into my equation, I know that p of -4 should be equal to 172 because that's what my remainder is. So let's just check. So if you go ahead and plug this into your calculator, you'll notice that you do get 172. If you don't for some reason, either you plugged it into your calculator incorrectly or maybe you did your synthetic division wrong, but you should get p of -4 equals 172. And this is really cool because that means that it's a way to check your long division or synthetic division. If I go back to my first page here, if I go to, let's look at B here. If I look at B, that means if I were to do p of 5, that means if I plug in 5, notice remember our remainder was 5, that means I should get 5 out when I do p of 5. So if you test that theory, you would have 5 squared plus 2 times 5 minus 30, and you'll notice that you get out that 5 that we have there. If I did this equation right here, so that means if I did p of 8, p of 8 is going to be equal to 0 because our remainder is 0. And then over on the next page, for these problems, if I did p of -1, it should be equal to -4 because my remainder was -4. And over here, if I do p of -1, I would get -10 because my remainder is -10. So it's a nice way to check your synthetic division or long division. So the last one says use synthetic division to find p of -1 for this. So that means if I plug -1 into my equation, whatever I get with my remainder for synthetic division would be my answer. So -1 goes in the box because if I were to write this as a linear factor, the factor would be x minus -1, which is x plus 1, so that's my factor. So that's why -1 goes in the box. This is 2, 6, -5, we're missing 0x minus 60. Don't forget those 0 placeholders. So I got a remainder of negative 69. So if I were to write this out, this would be 2x cubed plus, 4x squared minus 9x plus 9 minus my remainder over x plus 1. That's not what the question wanted. It wanted me to find p of negative 1. So p of negative 1 should be equal to negative 69. So if I check my answer, that means if I plug in negative 1 into the equation, I should end up with negative 69. So this one's easy to check. So negative 1 to the 4th power would just be 1. So this is 2. Negative 1 to the 3rd power would be negative 1, so minus 6. And then this is going to be plus 5, minus 60. Sorry, I forgot to square that negative 1, so this should be minus 5 right here. Oops. So minus 5 minus 60. So when I do that, I end up with running out of room. So this gives me negative 69, which checks out. So this is my answer. So now it's pretty cool because, again, we have a way to check our synthetic or long division. Easier way to do this would be to plug this in equation into your y equals and then just look at your table in order to get these values.